afternoon, sir. This is KUNAL JAISWAL, and I'm going to present my DA assignment on logistic regression, sir. I've implemented the code for logistic regression. I've imported the important library which are needed for the data to be processed, like pandas, NumPy, matplotlib, seaborn, and I've also imported some splitting method like train test split, and I've imported the model logistic regression from sklearn.linear model, and I've also imported the standard scalar library to standardize the all the features between 0 to 1 with standard deviation 1 and mean is equals to 0. Uh, Now coming to, I've also imported like in classification model, we have to check like precision, recall. We don't have to completely rely on accuracy score. So I have imported R2 score, confusion matrix, recall score, precision score, ROC AUC curve, and like classification report and confusion matrix display. So the dataset I've used is diabetes.csv, and we have features like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, outcome. Now, and the target variable is outcome. Now, moving ahead, as we can see, now we will like to have like if the data has some null values in it or not. So I've used the function like df dot is null dot mean. It will give the total percentage of null values in each feature, like pregnancy, and we can see that none of the columns have any null value. So So now I would like to see like are there outliers in the data or not. So we will use like box plot to see whether there are outliers or not. So the pregnancies column have minimal and glucose 2 have minimal outliers, and there are few in the blood pressure and skin thickness 2 have minimal. Insulin has the most outliers in the whole data set, and BMI also does have minimal, more than minimal outliers, and diabetes pedigree function does not seems to have outliers, and coming to age column to have some outliers. Now coming to the now, as we know, like pregnancies column can have zero values, but glucose column, blood pressure, skin thickness, insulin, BMI, and diabetes pedigree function and age, these all cannot be zero. So what I will do, like I will check which are all the features have zero in their uh, table. Then I've got like pregnancies have 111 zeros, glucose feature has 5 zeros, blood pressure feature has 35 zeros, skin thickness has 227 zeros, insulin has 374 zeros, BMI has 11 zeros, diabetes pedigree function does not have any zero, age does not have any zero. So what I will do, like we don't have to do anything with pregnancy, that it's practically like it can be zero, but glucose level, blood pressure, skin thickness, and insulin and BMI, it can be zero. So we will replace the zero with the median of the median of the each features. So it will, so that our data is not centralized like with mean, because we have the outlier, so I used median instead. Now uh, so after that, after doing replacing the values, I've got like none of the glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function does not have any zero values. As we can see clearly, it has been filled up with median values of individual column. So coming to next, what I'm going to do is checking whether the data is normally distributed or not. So for that I have used a histogram. So like yeah, wait. So the pregnancies have a normal distribution, but it is right skewed, and glucose is almost normalized. Blood pressure is also normalized. Skin thickness is slightly right skewed. Insulin is also normalized, but it is right skewed. BMI is a slightly right skewed, and diabetes pedigree function, it also is normalized, but right skewed. Age 2 is normalized but has right skewed, cause it all these have a bell shaped curve. So yeah, so I've plotted again the box plot, so to clearly with increase the flyer size, so we can see the data points or the outliers clearly. As we can see, pregnancies have some outliers, blood pressure have some outliers, skin thickness has some outliers, insulin there are plenty of outliers, BMI we have some outliers, diabetes pedigree function we too have some outliers, as we cannot see in the previous diagram. So age to have some outliers. Now we will try to remove some outliers. So I'm using like I'm not going for IQR function to remove. So instead I use percentile method to remove some top 2% or 1% or 5% data from the each features. So in the pregnancies, I've so since it has some outliers, so I removed 2% top 2% data from the pregnancies column using quantile function and giving the 0.98 as the 98th percentile we will retain, and 2 percentile we will remove that. Similarly for blood pressure, we will retain 99% of data and we will remove 1% of the data. And for the skin thickness, we will retain 99% of data. uh, Similarly for insulin, since it has most outliers, so we will retain 95% of data and remove 5% of the data from the insulin feature. And BMI we will retain 99% and remove 1%. And for the diabetes pedigree function too, we will remove like 1% of the data, and from the age 2 we will remove 1% of the data. So after removing all these, now I'm going to plot. I have plotted this box plot, as and we can see the pregnancies does not show any outlier. The glucose feature show little outlier here, and the blood pressure shows outlier, but they are quite fewer than the earlier. And skin thickness too has some outlier, but they got reduced. And insulin, which had highest number of outliers, has reduced clearly. Clearly, it has been reduced. In BMI, all the outliers have been removed. Diabetes pedigree function still have few outliers, and age too have few outliers still remaining. So now again, after doing the some uh, removing outliers, now we will try to see like whether our data is normalized now, or like normal skewed or right skewed or normal data. So pregnancy still is right skewed, glucose is normalized data, blood pressure is normalized data, skin thickness is normalized data, normal. Insulin is right skewed, BMI is slightly right skewed, and diabetes pedigree function is still right skewed, and age is still right skewed. So now we will divide our model. The target variable and the predictor variable. The predictor variable is x and target variable is y. All the columns we will take except for the outcome in x, and outcome column will be in y. And we can see like what are all the values we have in x. So coming to next, I have like while training the data we should have like a balanced data set, like number of patients having diabetes, yes, or patient having not diabetes, no, should be equal or in 60 to 40 ratio, like that, 6 to 1 6 to 40 ratio, like that, sir. So I plotted strip using strip plot. uh, so pregnancies have almost one and zeros and one, like similar in the and for the outcome value, sir. And for the glucose, we have like similar distribution for zero and one. And blood pressure too, we have similar distribution. Now wait, yes, sir. Now it will be clear. Yes, sir. So all three, like pregnancies, glucose, and blood pressure with respect to outcome, have a, balanced data set. And like skin thickness, insulin, and BMI, all these three too have balanced, uh, equally distributed data set. So and this diabetes, pedigree function, and age to have balanced data set. So we did not to apply like a smooth function to oversample or undersample our model regarding any of the classification. So moving ahead, I will use like standard scalar to normalize the mm, function or the features, and then I use like standard scalar function, and I've used fit transform to fit the data of x. We need not to apply for outcome column. So now I'm going to check for multicollinearity. So we can use like a correlation metrics, but it does not give like exactly how much value we should need for to accept or reject, like the features are um, linearly dependent on each other or not. So I've used rather variance inflation factor VIF. For that, I have used a variance inflation factor from stat models or outliers influence. And now, as we can see, VIF value ranges from 0 to 10. So value, if the value, no, it does not ranges from 0 to 10. If the value is between 0 to 10 or 0 to 5, we will say like the feature does not have any multicollinearity. So all the features like pregnancies, it has 1.44, which is less than 5. Glucose has 1.26, which is less than 5. Blood pressure is less than 5, which is 1.5, 1.2. So we can see every other features, all those have VIF, variance inflation factor, less than 5. So we can say there is no multicollinearity in our data set. So now we are going to split our data set with test size is 30% of the whole data set, and training size is 70% of the data set. Now I'm using the logistic regression function. Now what it will do, my brightness has gone down, sorry. Okay, then what I will do, like the I've used the object logic, and you unfit the model using X train and Y train. Sorry, I splitted the data like X train, X test, Y train, Y test. Now I call the function logistic regression. I've stored this in logit object, and then I call the fit function to fit the data X train and Y train. Now we will like uh, print like a Y predicted and Y score. Y score is to like Y score is it will give like 2 cross, like if the data set is m cross n matrix, then This will give like 2 cross n matrix y score, since our two column will be like 0 1 yes or no. So I've used only yes column, either whether the person is diabetic or not. Second column, so we will test like the probability of the person having diabetic or not. So for that I've used accuracy score. Our accuracy is 77%. But in classification problem, we need not to use accuracy score, since it is like a health condition problem. So we have to reduce like false negative features, false negative classifiers. So for that we use recall, which shows the how many false negative value we have predicted. Like it's recall is like true positive rates, yes sir. TPR. Now I have used like confusion matrix to see what y test and y predicted values are. So as we can see, there are 127. 127 is 0, means predicted 0, and actual 0 is 127, true negative. And 12 12 is false positive, 34 is false negative, 28 is true positive. Now we will check like accuracy. Our accuracy is same like 77%, like we have used like function up there. And the precision we use like there is 70% precision, but we do not have to take much consideration in precision. We have to take consideration on recall. So using recall I got like 45%, which is very less. That the model classified more than 55% of the people as false negative, whether but the person has diabetes, and our model predicted for negative to them, which is very bad. So we can call our model is very bad. So our F1 score is 2 is very low, 54 or 55%. So what I will do is I will like yeah, yeah. First we check like area under curve. Like it is right now 68 0.68. It is 0.68. Now what we are trying to do is we are trying to increase our AUC score, area under curve score. So this is our classification report. And now what moving to ROC term, we will use ROC curve function uh, with y test and y score. Y score is nothing but y probability of getting 1 by the positive diabetic person. So what? So I've used like FPR, TPR, and threshold. FPR means false positive rate. TPR means true positive rate, and thresholds like normally we use threshold like 0.5. Like if the data, if the function gives a greater than 0.5 value, then we will consider it as mm, 1. And if it is less than 0.5, it will consider as 0. 0 means no, 1 means yes, the person has diabetes means 1. So this ROC curve will give the thresholds TPR and FER with regarding to our Y score and Y test. Now what I will do, I will plot the data of the FPR and TPR, TPR versus FPR. So this is our data. The orange one is like is ROC, and as we can see, its area is 0.68. Now we can see that like there are plenty of thresholds here. Now we are going to find like which are all the threshold which will give us better best or better recall value, so that we can decrease negative, sorry, false negative values, yes sir, false negative. So what I will do, like it's optimal threshold. For optimal threshold, we will use like TPR minus FPR. Whatever the TP argmax, see TPR minus FPR, it will give three values like 0, 0.365, and again 0. Now we will take the uh, maximum number in all the columns, which our columns have maximum number. So it is on the second column or first index. So we will use np.argmax to get the that particular index, and that particular index will present in the threshold list. So using that, I've got like optimal threshold is 2.45, not zero point 0.5. So now I have used confusion matrix display for the threshold of zero point 0.5, and I've got like this thing, 127 true negative, 28 true positive, 34 false negative, 12 true negative. Sorry, false positive. Now we will predict our model for optimal threshold. For that, what we will do, like we will test. We will set like we will use function of numpy, where for that we will use like whichever the y score or y probability of a diabetic person is having more than optimal threshold, which we got like 0.245, not zero point 0.5. We will set that as 1, and which all the threshold probability value is less than 0.45445, we will set like 0 to them. Then again, we tested our recall score using that y test and y predicted with optimal threshold. We got our recall like 72.5%, which is way more better than 45% which we were getting earlier. So our precision score definitely has decreased. So because we do not have to worry much about the precision score, so I have used only recall score. Now coming to the confusion matrix, after choosing optimal threshold, we've got like very few false negative, very few, like 17, just 17. Now it's the confusion matrix, which we got earlier versus now. The false negative is drastically decreased from, now it's 17, it was 34 earlier. So 50% decrease is a good uh, model we got. So again, we will, yeah, that's it for now, sir. And yeah, FP, FPR after that is 2.5.251, and TPR sensitivity or recall is 72.5, which is pretty good for our model, sir. Thank you, sir.